So let's talk about some pretty famous and useful properties that are used in math and most especially in algebra. And these are the properties of addition and multiplication. And in math, properties are just statements that are true for any numbers. So, for example, 30 plus 10 is the same as, 30 plus 10 is 40, right? Is the same as 10 plus 30. That equals 40. And that particular illustration is showing you the commutative property, that any two numbers can be added in any order and you still get the same answer. So the commutative property applies for addition and multiplication, because, for example, if we did 30 times 10, we would get 300. And if we did 30, let me get my little eraser here. My brain's thinking ahead of me. 30 times 10, so we reverse the order, we still get 300. So the commutative property applies to addition and multiplication. The reason why it applies to both is, remember that multiplication is just repeated addition. So properties that apply to addition will often apply to multiplication. So in mathy language, the commutative property says that for any number A, oops, I'm moving this stuff around bizarrely here in my pen. For any number A plus B, that equals B plus A. And I just noticed that I wrote 30 times 10 equals 300 and wrote 30 times 10 equals 300 again. Down here where I wanted to show the multiplication of a commutative property, let's erase this. Well, can I erase it? I guess not. We'll just have to say that this here needs to, this down here, 10 times 30. That's what I wanted to say. So I got a little thrown off. So to clarify, commutative property for multiplication, you can multiply in any order. So 30 times 10 is 300, or 10 times 30 is 300. The associative property of addition and multiplication states that in mathy language, for any number A plus B plus C, we can add those in any order and still get the same answer. We could have A plus C plus B, or B plus A plus C, or C plus A plus B. You could do a whole bunch of different ways of organizing those three variables, and you would still get the same answer. So in other words, 1 plus 2 plus 3 is the same as 1 plus 3 plus 2. Do you agree? We'd have 1 plus 2 is 3, 3 plus 3 is 6, or 1 plus 3 is 4, and 4 plus 2 is 6. So the associative property says that we can group together any numbers and add them in any order and get the same answer. It also applies for multiplication, because again, multiplication is repeated addition. This is very helpful because when you get long, expressions of numbers or variables and you want to combine them, you can kind of bounce around and do that in addition or multiplication because you're using the associative property. I tell my students how to keep the two kind of separate in your head between the commutative property and the associative property. Associative property reminds me of association, and associations are made up of lots of people. So you have more than two numbers. You have lots of numbers. They can associate with each other. That's the associative property. Then there's some pretty important number properties to discuss and remember, and they seem pretty clear. The additive identity property means that we can add 0 to anything, and we're still going to get the same number. So in other words, 5 plus 0 equals 5. It's additive identity. 0 added to anything is still itself, its identity. So myself. I put a 0 added next to me, I'm still myself. It's still the identity. Now that doesn't work if you times by 0. That's the multiplicative property of 0. And if we have 5 times 0, we're going to always get 0. So any number times 0 is always 0. That's the multiplicative property of 0. 5 times 0 is 0. The additive identity property is adding 0 to a number and always getting the same number. Multiplicative identity is times 1. So any number times 1 is always itself. So in other words, 5 times 1 is always going to be 5. There's always a 1 standing next to everything, multiplying it, and you're still going to get its identity. You're still going to get itself. Now, we bring up the term counterexample to show that a conjecture is not true. So, in other words, these properties that we've discussed, like commutative and associative property, they apply, the commutative and associative property apply to addition and multiplication, but they don't apply to division and subtraction. And you can show this with a counterexample. If we had 3 minus 2, that's 1. But if we flip it around and say 2 minus 3, we end up with negative 1. So this here, this 2 minus 3 equals negative 1, that's a counterexample showing that we cannot flip these two back and forth, and the commutative property applies for subtraction. Likewise, if we did 4 divided by 2, we would get 2. But if we did 2 divided by 4, we would end up with 1/2. You can't do it for division either. There's no commutative property for division. Additionally, associative property works the same way. If we can't mix them up and do them in any order in commutative property, we cannot do it in associative property. But these are examples of counterexamples to show that a conjecture, a statement, is not true for certain things. So remember that associative and commutative property work for addition and multiplication, but they do not work for subtraction and division. Let's practice kind of identifying some properties if you were to see them. What if you had 4 plus open paren a plus 3, that equals open paren a plus 3 close paren plus 4. What property is that demonstrating? Well, that's showing the associative property. We can add in any order, and we're still going to get the same answer. What if we had 1 times 3c, and that equals 3c? What property is that using? And that would be the multiplicative identity property. Anything times 1 is always itself. So 1 times 3c is always going to be 3c. And finally, to bring it all together as to why you use these properties, why you have these properties, is you use them to simplify algebraic expressions. So if I had 3 plus e in parens, so open paren 3 plus e, plus 7, I could simplify this using the associative property, because I could take the 3 and the 7 and choose to add them together and then add the e onto it. So I'd have the 3 plus the 7, then plus the e. So 3 plus 7 is 10. I'd end up with 10 plus e. More practice at simplifying expressions. What if you had 8 times open paren 5 times x? Well, again, I can multiply in any order using the associative property, so I could choose to go ahead and multiply the 8 and the 5, and I would end up with 40 and x. So simplified, 8 times 5 times x is actually 40x. In other words, we have 5 x's. We're going to multiply them 8 times. That means we're going to have 40 x's. Let's try another one. We would have 10 plus open paren p plus 18. We can choose to combine that 18 and 10 because we can jump around and use the associative property in addition, so we'd have 28. And what do we have left over? The plus p. Or we could do 12 times 10 times z. Well, we can do the 12 times 10 and have 120 z. So to review, commutative property says that we can add any two numbers or multiply any two numbers in order. So 2 plus 3 is the same as 3 plus 2. And 2 times 3 is the same as 3 times 2. Associative, very similar. It just means we can do it with more than two numbers. So if we had 2 plus 3 plus 4, that could equal 2 plus 4 plus 3, or several other examples. Likewise, if we had 2 times 3 times 4, I could bounce around and decide to multiply 2 times 4 first, and then times 3. The identity property of addition means that I can add 0 to anything, and I'm always going to get itself. So 2 plus 0 is going to equal 2. The identity property of multiplication states that I can multiply anything by 1. So 2 times 1 equals 2. And then finally, the multiplicative property of 0 says that any number times 0 is 0. So if I have 3 times 0, I'm going to get 0. In other words, if I have 3 zeros, that's 0 plus 0 plus 0, that's 0. Multiple zeros is always 0.